welcome to another edition of Blunderverse. My name is Neil Shaw, editor of Blunderverse. Blunderverse's mission is to capture and share with you some of the latest events in astronomy, wherever opportunity strikes. In June 2010, I caught up with Associate Professor David Coward, Director of Zadko Telescope, and Dr. Laas-Bourez, Zadko Telescope Systems Manager at the International Centre for Radio Astronomy Research, UWA. David and Mirti share with us some details of what the aims and ambitions are for the Zadko Telescope project.
Welcome, Professor David Coward and Dr. Mirti Laas-Bourez. Both of you are actually working on the Zadko project, and certainly you're going to tell us today all about this exciting project. Perhaps first of all, before we go into that, perhaps David, you can actually tell us a little bit about how you got into astronomy and astrophysics.
I've had a fairly convoluted path into research. I always had a fascination for astronomy when I was very, very young, but I got distracted and had various careers ranging from working in horticulture to growing bonsai trees and selling bonsai trees. And it wasn't until I was actually in my late 20s when I decided to do a degree in environmental science, of all things. And then that progressed into a degree in physics and mathematics. And then at the end of that, I had to make a crunch decision and say, what do I really want to be doing? And I thought astronomy. And at that time, there wasn't really any degree in astronomy in Australia. So I took another, strange path. I worked in gravitational wave research. Gravitational waves were predicted by Einstein, but they haven't been detected yet. And there is a research project at the University of Western Australia, and I did a PhD in mostly theory in predicting the sources of gravitational waves, exotic things like black holes and neutron stars. So that was my non-standard entrance into the world of astronomy.
Right, that sounds like you're really into the thick of it. Very heavy-duty astronomy there. Mirti, tell us about your interest. How did you get started?
When I was young, I used to go to see all the Perseid in August, the Perseid meteorites in August with my family, and spend all the night just looking at the meteorite. And I was always keen on astronomy. But during my study, I didn't go in astronomy way, but I moved after my master research degree. I make a training of engineering in the Observatoire Haute-Provence, which is an observatory in France. And I was involved in a very good project in astronomy and space debris research. So I make a PhD in this observatory, and now I'm really on astronomy.
Right. You haven't stopped enjoying the subject so much. And that's good.
Actually, I'm employed by University of Western Australia for 1 year. It's a 1 year appointment with ICRAR, which is the Radio Astronomy Center of UWA, and half with the School of Physics with David.
Cool. Perhaps, David, you can actually just tell us a little bit about, give us an overview of the project and what it's about.
Well, the Zadko Telescope project is interesting from many aspects, and even the name, the Zadko Telescope, has got an unusual ring to it, because we were lucky to have a large philanthropic donation to the University of Western Australia, and that allowed funds to be provided specifically for the construction of a 1 metre robotic telescope. And these funds came from a very generous donation from a resource company in Western Australia, and it was unprecedented up until that time, a few years ago, to have a resource company inject money purely for science, education and research in astronomy. And the Zadko Telescope is a telescope that is robotic in the sense that it is connected to other telescopes in the world, and it interacts and does imaging without human intervention. There are many telescopes which are internet telescopes, but this telescope is connected directly to satellites, and it can respond to satellites, and it can also respond to other types of telescopes. The key science for the Zadko Telescope again is very exciting and unique. The Zadko Telescope is used to probe the so-called Transient Universe. Transients are things that don't last very long. They either flash or they move across the sky very quickly. A good example of a transient is a thing called a gamma ray burst, which is a flash of high energy radiation from a star exploding at the edge of the universe. These only last for maybe seconds to a few hours, and so the Zadko Telescope can observe and image and study exploding stars at the edge of the known universe, and also track dangerous space debris only a few hundred kilometres above the Earth. And so we're probing the transient universe back to about 11 billion years in our history, back to objects which are in our own space-time.
Okay, and in terms of the gamma ray bursts, how important are they to science in terms of understanding? What are we trying to actually learn from these gamma ray bursts?
This is a very new thing. Gamma ray burst is very new research field. It's began in 60s, I think 40 years ago, and because some American satellite discovered this very, very high energy flash in the universe, and they didn't know when and where this appeared, and we need to be very, very fast to have image of these things, and so it's why we are still trying to make image of this, because we didn't have any a lot of this for the moment. So
right, and I believe one of the other aspects is to see how gamma ray bursts actually interact with the interstellar medium. I believe, is that one of the area of research?
Well, gamma ray bursts, like Myrti mentioned, is that they were enshrouded in mystery from the early days. They were kept top secret by the military. In the 1970s, it was realised they weren't nuclear explosions going off on the ground. They were nuclear explosions going off somewhere out in the cosmos. Now we believe they are high energy explosions, and it's a little bit like holding a candle in a dark room. You light the candle and the room is illuminated. That's what a gamma ray burst does to its host galaxy, the galaxy where it lives, with millions of stars like our Milky Way, but this is a galaxy that is billions of light years away. So the gamma ray burst is like a torch, it's like a light that exposes the environment around it. And so it's a way of actually probing the universe back in time, back 11, 12 billion years ago, where light struggles to reach us because it has to travel so far. So it is very hard to find a bright light that far away, and gamma ray bursts is like a person with a torch shining around a dark room.
And we can have image for something very, very, very far with our telescope. So it's something very good for the science to discover what's happened on the beginning of the universe, you know.
So can we